So, good morning, everyone. I am Nandhini, Assistant Professor, Department of Electronics and Communication Engineering, uh, Tech Multitech Dr.Rangarajan, Dr.Sakunthala Engineering College. So, today I am going to share a few ideas regarding this multiple access technique. So, this multiple access schemes will be allowing many mobile users to share simultaneous here a finite amount of radio spectrum here. So when you're going for this multiple access techniques, mostly in wireless communication system, it is very often desirable to allow the subscriber to send information simultaneously, so from the mobile station to the base station. So while receiving the information from the base station, it is very desirable. So what happens here, in a cellular system, it is going to divide a number of given area into cells, and mobile unit in each cell communicates with the base station. So here the main aim in the cellular system design is to able to increase the capacity of the channel, that is to handle as many calls as possible in a given bandwidth with sufficient level of quality of service. So we are having a number of different ways to allow access to the access to the channel. So these includes mainly like frequency division multiple access, time division multiple access, code division multiple access, and space division multiple access. Mainly we are accessing using this division multiple access techniques only, that is a frequency, time division, code division, and space also. So this is the outline content we are going to share. So first of all, we will be seeing about this frequency division multiple access, that is FDMA. So it is a basic technology for the advanced mobile phone services. So it is having a single channel per carrier. So for first generations we use this system for the data transmission and reception. So we are having a few features for this FDMA, that is FDMA, that is a frequency division multiple access, allots a different subband for frequency to each different users to access the network. So if FDMA is not in use, what happens, the channel is left ideal instead of allotting to the other users. So this is implemented in narrowband systems, and it is less complex than the TDMA. So here we'll be having a tight filtering. We'll be doing the tight filtering where to reduce the adjacent channel interference. So next is the base station and the mobile station will be transmitting and receiving simultaneously and continuously in this frequency division multiple access. Next one, we are going for this time division multiple access. So in case where continuous transmission is not required, this time division multiple access is used instead of this FDMA. So we are having multiple channels per carrier here, and in most of second generation systems only we are using this TDMA. In first generation we have used FDMA, and in second generation systems we are going to use this TDMA. So we are having a few features for this TDMA. So it is sharing a single carrier frequency only with several users, so where each users make use of non-overlapping time slots. So in data transmission in TDMA is not continuous, okay, so but it occurs in bursts. So here it is hands off process will be simpler here. So next is this TDMA uses different time slots, as I said before, for transmission and reception. So duplexes are not required here. So next is the main advantage for TDMA is it is possible to allocate different number of time slots for per frame to different users here. So here in this bandwidth, when coming to bandwidth, it can be supplied on demand to different users by reassigning time slots based on their priority here. So next, when you're going for this code division multiple access, so here this technique is an example for multiple access where several transmitters uses a single channel to send information simultaneously. So here users can share the bandwidth by code sequences. Okay, so next is in some second generation systems also we used CDMA, and most of the third generation systems only we are using this CDMA. So Here also we are having a few features for this CDMA. What are the features is every user uses a full available spectrum instead of getting allotted by the separate frequency. So the CDMA is much recommended for voice and data communication. So while multiple code access occupy the same channel in CDMA, the users having same code can communicate with each other here. In it is so it also offers more airspace capacity than TDMA. So in this, the hands off between base station is very well handled by the CDMA. So when you're going for the types of channels, here we are having two types of channels: control channels and traffic channels. Under control channels we are having forward or downlink control channels, and reverse or uplink control channels. In traffic channel we are having two types, that is a forward traffic or information channel and reverse traffic information channel. So when you are seeing about this channels, we can see how the reverse channel and control channels are working from this mobile station to the base station. So here down it's shown the traffic channels, and upper part we are showing the reverse channel, that is uplink control channels, and the down part we are showing the forward channels for the downlink. So when you're coming for this FDME again, so as I said before, in FDME what happens, the frequency levels will be distributed, that is allotted to different subbands of the frequency. So it is shown for different frequency levels, ms1, ms2, ms3 till msn, that is a reverse channel, that is upper link, that is, and in the right side shows the forward channels to the base station, that is the downlink. When you're going for this channel structure, the total bandwidth is calculated using the formula W equal to NWC. Here we can see the value WC is between the slots 3 and 4, and God band WG is calculated between 1 and 2. God band is the frequency level which is not used between slots 1 and 2. So 1 and 2, when it is not used, it avoids the interferences between the user 1 and user 2. So for frequency for all the users is given here. Next is the TDMA. So in TDMA, here it will be sharing a single carrier frequency with several users. So where the users can use of this and non-overlapping can be done here for using the time slots. So as I said, left side is the reverse channels uplink is shown, and right side forward channels downlink is shown, and how the frames are separated is given here. So this is the channel structure for TDMA. So above is the forward channel, and the same for in the receiver side is it's shown for the reverse channel also. So this is the frame structure, how the forward channel and reverse channel is framed. So here, as I said, how the guard band is given, head is given, and data is given. When you're taking a time division multiple access, when you're taking a single slot, that is a single data, it is transmitted using the guard band at the front, and following by the head and given to the data. So likewise, all the data using this time division multiple access are transmitted. So when you're coming for this code division multiple access, so code division multiple access also we are having the mobile station and the base station, where reverse channels are given in the ms time, and in the forward channels we are giving the base stations. So here all the users will be using the available spectrum, so instead of getting allotted by separate frequency here. So while multiple codes occupy the same channels, no, here the users will be having the same code to communicate with each other. So this is the comparison of FDMA and TDMA with the CDMA. So this is the operations for allocated bandwidth, frequency reuse, how the required channel bandwidth is given, how the control channel is given, and everything. So this is the few comparisons between FDMA, TDMA and CDMA. So when you're going for this direct sequence spread spectrum for this CDMA, we can see how the transmitter and receiver is given here. So in this is a most commonly used technology for CDMA. So this DSSS, that is direct sequence spread spectrum,
the message signal will be multiplied by the pseudo random noise here. So here in this, the each user will be given by his own code word, which is orthogonal to the codes of the other user. So in order to detect the user, and the receiver must know the code word used by the transmitter. So this combinational sequence is called the hybrid and also used to another type of spread spectrum here. So this is the transmitter side and receiver side, how the power and frequency is differentiated at transmitter side and receiver side is given. So in the transmitter side, the spreading is given multiplied for with the digital signal and the code, and receiver side also the spreading signal is given as the input to the receiver, that is here in the receiver despreading with the code is given, output is digital signal. Next is the concept of frequency hopping spectrum also. It is the same, that is here will be having a time hopping, that is when compared with digital multiple access system, here the carrier frequency will be used by the individual users, and varied pseudo random fashion will be given for this wideband channel. So here the digital data will be broken into uniform size bus, so then transmitted into different carrier frequencies here. Same as I said before, here also we are having transmitter and receiver side. In transmitter side we will be using the spreading, and receiver side we will be using the despread. We are using the multiplier here, where we are using digital signal and the hopping pattern in the transmitter side, and same way in the receiver side also we are using the input spreading signal for hopping pattern to get the despread, and digital signal is obtained at the receiver side. So this is an example for frequency hopping, where how the frequency is hop, that is changed from one to another with the time. So when you're going for this orthogonal codes, how the codes are varied. So this is the near far problem here. So when you're going for this near far problem in this multiple axis, so for example we are taking two mobile stations, that is two users with the same base station. So more than number of users can be used for the transmitter and receiver in the single base station here. So here it is shown how the mobile station 1 and mobile station 2 is differed along with the distances d1 and d2. So how the received signal strength will be given. So when you're going for this interferences, we are having two types of interferences, types of interference. We have many types of interference. So how the interferences are given using this PET spectrum in CDMA. So the first figure shows first the baseband signal with the frequency, and next is the baseband signal for spreading signal, how it happens in the interferences. So when despread signal, how the interference signals are happening. So this is the adjacent channel interference, how the channel 1 and channel 2 is having the interference with the power and frequency. So F1, F2 is the frequency levels, and channel 1 and 2 is the number of channels when data transmission is done. So this is the power control formula, how we are going to calculate the power control in CDMA. So this controlling transmission power affects the CIR here, that is PR by PT equal to 1 by 4 by dF by C into alpha. So alpha is the attenuation constant, which can be from the value 2 to 4. C is the speed of light, F is the frequency of transmission, and D is the distance between receiver and transmitter. Received power in free space can be given by PR, and transmitted power is given by PT. So next is the modulation. So why we are going for the modulation is we need the antenna to be in the small size. So when antenna to be in the small size, what happens? It is inversely proportional to the frequency. So for example, we are going for 3 kilohertz frequency level, the antenna should be in the 50 kilometer. When frequency level is 3 gigahertz, the antenna level should be in the 5 centimeter. So we must have the limits, noise and interferences also. Example, frequency modulation, and many multiple techniques are used. Example, FDMA, TDM and CDMA. So this is the analog and digital signals, how the from the transmitter side to receiver is sent, or from the transmitter to receiver is transmitted. So this is the analog signal, continuous signal, and digital signal is the discrete signal. So this is the hearing, speech and voice band channels. How the human hearing value is given, how the human speech value is given according to the frequency, and how the channel is separated, how the guard band is given using the frequency cutoff point for the transmission of the human hearing and human speech voice, a great telephone here. So this is the amplitude modulation wave, how it is shown. So in order to send the informations, we can use this amplitude modulation also. So it shows that amplitude of the carrier is showed varied as the message signal to be transmitted. Here the frequency carrier signal will be kept constant, only the amplitude of the carrier signal will be varied. When coming to the frequency modulation technique, here the frequency modulation will be changed. This frequency will be changed in message signal with carrier signal. So here when instantaneously frequency level is changed, the modulation is occurring, amplitude will be kept constant in this frequency modulation. So thank you.